I had a friend today ask me a great question, and I thought, you know what, I'm going to make it into a video because it was such a great question. So the question reads, when iron rusts in the air, iron 3 oxide is produced. How many moles of oxygen react with 1.2 moles of iron in the rusting reaction? Well, first things first, let's write down what we have. So we know that we have iron 3 oxide. All right. So let's see, iron 3 oxide. So the first part of the problem is a balancing of the equation. So what we have over here in the products, we know we have to have in the reactants. Draw an arrow. We have iron, so we know we have to have iron over here. And then we have oxygen, so we know we have to have oxygen over there. First things first, 2 irons on this side, which means we need 2 irons on this side. And this is where the problem gets interesting. What is the subscript of this oxygen here? You might think just to throw a 3 right here and call it a day. However, that's incorrect. Now to me, when I saw this problem, I thought it was obvious that it was O2, but I have a chemistry degree, so to me that very obvious thing was not so obvious to someone who's learning this for the first time. So I thought this is why this is such a great problem. So oxygen has generally 3 forms that it takes. The first form, atomic oxygen, is just a single little oxygen all by itself. This kind of oxygen doesn't exist naturally very long because it's very reactive and unstable. In space, however, there's plenty of ultraviolet radiation, so O2 molecules are broken apart easily and they create these atomic oxygens. The next one, molecular oxygen, is the air we breathe. It's the most stable. So think about it. You have your little O2, or your little O's, and they're like, hey, here I am just free floating. And this little one's like, yeah, I'm also just free floating. Did we just become best friends? Heck yeah, they did. Look at that, beautiful. So now they're gonna be happy floating together. Like, yay, we're best friends. Here they were maybe not so happy because they're like, oh, we're not gonna last very long because we're unstable. Here, stable, they're happy. So just remember that. These guys, these are the air we breathe. They're happy, they're stable. So O2, air we breathe. So they have no unpaired electrons here. They make up 21% of our atmosphere. Now the very last one, O3, is, well, 3 little oxygens. It's mostly found in Earth's upper atmosphere. But yeah, that's the 3 forms that they, exist in. So when you're doing these problems, air. If it says air, you know that it's going to be O2. So that's kind of where I was getting with this. Like, if you didn't know what form of oxygen to use, now you know. If it says air and it's, iron and air reacting, it's going to be O2, the air we breathe. Okay, so sidetrack from that, now we're over here. So now we need to balance this. We have 3 oxygen on the right and 2 oxygen on the left. Well, the only sensible thing to do to make it is 6, because we can do that to both to make it equal. However, now that changes the amount of irons, which is easily fixed. Beautiful, that is a balanced equation. So now we can go on to part 2 of the problem. We have 1.2 moles of iron. Okay, how many moles of oxygen are going to react with that? So let's see, 1.2 moles of iron. Okay, well, looking right here, we know that 4 moles of iron react with oxygen. There. 3 moles up here. All right, when you do the math, that equals 0.9 moles of O2, and that is your answer. Sweet. Hopefully that made sense. If it didn't, please leave a comment below and I can further explain it. Or if you have a question similar to this, or maybe not even similar to this, just leave a comment below and I'll be sure to answer it.